Okay, so I'm going to try to go through this pretty quickly. I started with complex numbers. Remember, I is the square root of -1. So basically, anytime there's an anytime there is a negative inside of a radical or inside a square root, you need to get rid of that negative by bringing out an I. And I squared is equal to -1. Anytime you see an I squared, replace it with -1. For adding and subtracting, it's the same as just combining your like terms with variables. But remember, if you're subtracting a binomial, you need to distribute the negative into that binomial and then combine your like terms. Multiplying, all you're doing is distributing the terms. If it's two binomials, remember to use the FOIL or distribute twice. And when you have a I term times an I term, it's going to become I squared, and then that's when you replace it with -1. And basically that term changes sign and you get rid of the I squared. To divide, you're multiplying both the numerator and the denominator by the denominator's conjugate, which if you have a plus bi, the conjugate is a minus bi. You don't change the sign of the front one, only the sign between the two terms. And what should happen, they don't cancel each other out completely. You still have a denominator there. But what should happen is that the i's will cancel out. Solve by factoring. Get everything on one side and have it equal 0. So once you get into solving, starting the problem correctly is the first key step. Make sure you're doing the right steps. So with factoring, you want everything on one side equal to 0. And then you're going to factor. Remember to always, always, always check for your GCF. It may not be possible, but always check, including the variable. The variable can be a part of the GCF if every term has that variable. And then you have your zero product property, which says if A times B is equal to 0, then A is equal to 0 and B is equal to 0. You still need to solve this. Okay, so set each parentheses equal to 0 or each thing being multiplied equal to 0 and solve. With the quadratic formula, I've written it here, -b plus or minus the square root of b squared minus 4ac all over 2 times a. For this one, you're going to get everything on one side and have it equal to 0 as well. Label your a, b, and c, and then you plug it in and simplifying it. Just make sure you simplify correctly. Do what's inside the radical first. If that radical can be simplified, simplify using birthday cake factor tree. Check for any i's. If it's a negative, you bring out an I. And reduce if each term can be simplified by the same factor. Remember, you can't simplify with anything inside of the radical, but only the things that are on the outside. With completing the square, get it in the right form. This is the one that is different. You want the x squared and the bx on one side, and you want the constant on the other. So x squared plus bx equals c, but your a has to be a 1. So if there is an a that's not a 1, you need to divide every term by that a. You write that if you need to. Complete into the perfect square trinomial by finding b over 2 squared. You're going to add that to both sides. I highlighted this because a lot of people still only did it to the 1. You need to do it to both sides. And then you factor it and solve by square roots. Take the square root of both sides and solve for x or whatever the variable is. And the last couple things, the discriminant is just the part of the quadratic formula b squared minus 4ac. If that number, once it's simplified, is positive or greater than 0, there's 2 real solutions. If that number is a perfect square, then the 2 real solutions are rational. If there's still a radical when it's simplified, then that number is an irrational. If that number in the discriminant is less than 0, then there's 2 imaginary solutions because it's a negative that's going to be inside of the radical, so it becomes imaginary. And if the discriminant is equal to 0, then there's only 1 real solution, and that one is going to be rational. Exponents on the i's. It's the pattern of 4. So I squared, I to the third, I to the fourth. is I, -1, -I, and +1. Remember, divide the exponent by 4, and what's important is the remainder, and whatever the remainder is going to be equivalent to these exponents. So remainder of 1 is equal to I, remainder of 2 is equal to -1, remainder of 3 is equal to -I, and if it goes in evenly, then it's equal to +1. What do you call a king's sore throat? A royal pain in the neck. Oh! Royal pain in the neck. Royal, because he's a king.